Assalamu alaikum. Today we're going to start our new chapter, chapter number 9, which is volumes, basically. Page number 150. Yeah, page 150. Basically, first we're going to understand what is volume, what is area itself, what is surface area, what is cubes, and what is cuboids, okay? So, step by step, first basic thing, in chapter number 8, we've already done area, so basic recap of what area is, okay? You have basically this, what is this? A square, you have this, which is a rectangle. A square has all sides equal to one another, and a rectangle has opposite sides equal, okay? So let's say if this is length and this is breadth, so length multiplied by breadth would have been your area, right? You've done this in chapter number 8. And in square we have sides, okay? Or simply you can say this is also L, if this is L, this is L, so length multiplied by length. This will give you your area. Now, this is the basics we've done in the previous chapter, right? What is the definition of area itself? Basically, area is the space inside a 2D shape, a flat shape. For example, space inside a square or circle. Any shape that you can draw on a piece of paper, anything that is 2D, even your pictures, okay? Anything like that which is 2D. The space inside it, for example, even this random shape. The space inside this random shape is going to be area, okay? It's 2D, it's on a flat surface, so it will have area. Again, area is the space inside 2D shapes. What is volume? Volume is space inside 3D shapes. What is 3D shapes? Any real object. This pen, it's a real object, so it will have volume inside it. The space inside this pen will be its volume. For example, this book, it's a real object, so the space inside this book will be volume. I have this marker, the space inside this marker will be what? Volume. You humans, we have humans, right? Humans have space inside them, or they can have a volume. Anything that is real object, any real matter will have space inside them, whether it is filled, whether it is hollow, the space inside it will be volume, okay? So space inside water bottles, we have the space inside balloons and boxes as well. So both of them are space inside something, but area is related to 2D things and volume is related to 3D shapes, okay? That's the difference between volume and area. That's really important for you to understand, okay? And then we have area, which is measured in meters cube. For example, we have length. How do we measure length? In centimeters. This is 1 centimeter. I can make a line. Look, that would be a 10 centimeter line almost, right? This is length. I'm measuring length right now. This is a 10 centimeter line, okay? So length is measured in what? Centimeters, meters, kilometers, and area is measured in what? Centimeter square, meter square, millimeter square, kilometer square, and all the units of length in squares, okay? Volume is measured in what? Volume is measured in liters, meter cube, centimeter cube, or you can also say basically the right way of saying this would be cubic meter or cubic centimeter or cubic millimeter, and this one would be square meter, square centimeter, square millimeter. The proper pronunciation, the proper way of saying it would be like that, okay? This is basics what we have done already in grade 5, okay? Other than that, what is surface area? Surface area is area similar to that, but it's a bit different, okay? Surface area is basically the total area of all the faces of a real object. What does that mean? I have a Rubik's Cube here. A Rubik's Cube is basically a cube, right? It's a real object. It has length. Basically this, let's just say this is length, this is breadth, and this is our height, right? Length, breadth, and our height. So it's a cube, right? If it's a cube, it has a top face, face on the bottom as well, and 1, 2, 3, 4 faces other than that, right? Front face, okay, you could say if this is top, this is bottom, right? Bottom face, then this is front, this is back, this is left, this is right. A total of how many faces do I have here? 6 faces, right? So each one of those faces is what? A square. This is a square, this is also a square, this is also a square. All of them are squares, right? Each square will have its own area. We already did that. We said area's formula is what? Length multiplied by length for a square, right? So total area of all the faces. For example, I have this length multiplied by length of this one, length multiplied by length here, length multiplied by length here. If I add all of them together, that will be the total surface area, okay? That's what surface area means. This was a simple shape, a cube, right? But I can have more complex shapes, and every shape, for example, every real object has an external face. My hand has an external face. This is the external face top, this is the external face of the bottom. I have the thickness here, right? So if I add the area of all of them together, then I will have what? I will have the surface area of my hand. So any real object has external faces. If you basically find the area of each and every face and add them all together, that will be the total surface area of that thing. What is a cube? A cube is a real object, a 3D object with 6 faces that are square. Okay, this is a cube. It has 6 faces: 1, 2, 3, 4, 5 and 6. It has 6 faces, all of them are squares. Okay, it has 6 faces that are square and then 8 equal lengths, edges. What do I mean by that? I have this length, this length, this length and this length, right? 4 here, 1, 2, 3, 4. Edges and sides basically means the same thing. So 1, 2, 3, 4. 4 here, 4 on the bottom, 1, 2, 3, 4, right? And 1, 2, 3, 4. 4 like this as well. So, oh, wait a second. Okay. So, oh yeah, so it has 4 on the top, 4 on the bottoms, and 1, 2, 3, 4. 4 on the sides. So it's not 8. It's 12. 4 plus 4 plus 4 is 12, right? So 12 equal lengths, 12 equal edges. It has 12 equal sides. For example, if this is 4 centimeter, all the other edges, all the other sides that you're seeing, they will all be 8 centimeter as well. If this is 4 centimeter, then all of them will be 4. If this is 6 centimeter, then all of them will be 6. Okay, that's what a cube is. Cube has all sides that are equal. Then we have 8 vertices. Vertices means corners. Just a reminder, this is a corner, this is a vertex. Okay, 1 vertex, 2 vertex, 3 vertex, 4 vertex, right? And 4 on the bottom as well, making a complete 8. It has a total of 8 vertices. Okay, all right angled. Like for example, this has a 90-degree angle here, this has a 90-degree angle here, 90-degree angle here as well, 90-degree angle here as well. Every angle that you see will be a 90 degree, because all angles inside a square are what? 90 degrees. So in cube as well, you have 90-degree angles. Basic simple things that you need to remember about cube: 6 faces, 12 sides, edges. It has 8 vertices, all right angles. Best example of a cube, you will have your Rubik's cube with you. Okay, how to draw a cube? You will basically make shapes like this, and you've done this in grade 5. So this is just a basic recap for if you have forgotten, some of them who you have forgotten these things. Okay, what is a cuboid? A cuboid is a real object, a 3-dimensional solid shape. Okay, this is a 3D cube, right? Let me bring my if I have an example of a cuboid. Okay, a cuboid will have what? 6 rectangular faces or 4 rectangular faces and 2 square faces. What do I mean? First of all, 6 rectangular faces. Take a look at this. It's a box, a rectangular box, right? So what do I have here? I have a rectangular face on the top and a rectangular face on the bottom. Then I have a rectangular face on the left side and the right side as well. Okay, here I have a rectangular face, here I have a rectangular face, and on the front and on the back as well I have rectangular faces. All of them are rectangles, so I have 6 rectangular faces, right? Then I have 4 rectangles or 2 squares. This is the second option I have. For example, look at this box. I have rectangular face here, rectangular face here, rectangular face here, and rectangular face here as well. Then I have a square here and a square here. Most likely you can say a brick face as well. So these both are the examples of what? Cuboid. These are both cuboids. It can have 2 square faces or 4 rectangular, or it can have all 6 rectangular faces. Other than that, it has the same 8 vertices, all of them right angled, 12 edges and sides, the same as cube, right? The rest of the things are pretty much same, but this is the difference, that it has rectangular faces. Okay, you can draw a cuboid like this. And now we're going to talk about the conversion of units. Before we go into the further details of what volume is and what how we're going to deal with it, first we're going to deal with the conversion of units. We've done this before in chapter number 8, but that was related to area. In chapter number 8, if you recall correctly, let me go to chapter number 8. We did the conversion of units in chapter number 8, but there we converted what? We converted meters into centimeters, meter square into centimeter square. We converted basically that's what we did, right? Anything else? Probably no. Here we're going to convert something else. Wait a second. Oh, yeah. Conversion of units here will involve the units of volume. What are the units of volume? We've done this before. Units of volume involve liters, meters cube, centimeter cube. Basically, we're going to learn about the conversion of liters into meter cube and meter cube into liters, or centimeter cube into meter cube and stuff like that. First and the most basic thing that you need to understand here. 1 milliliter is equal to 1. You have already done this much as well in the 5th grade. 1 milliliter is equal to 1 centimeter cube. So if I tell you that you have 56, let's just say you have 56 milliliter, how much is that in centimeter cube or cubic centimeter? Is going to be 56 cubic centimeter. Same thing, right? If you have, let's say, whatever number you have of milliliter will be the exact same of in the centimeter cube as well. Okay, now you have 1 liter. 1 liter is equal to 1000 milliliters, and 1000 milliliter is obviously going to be equal to 1000 cubic centimeter as well. So if you have a liter and you want to convert it in either one of these, you're going to have to do what? Multiply 1000. So liters converted into milliliters or cubic centimeter is going to be equal to multiply by 1000 with that. Okay, and if you want to convert milliliters or cubic centimeters into liters, you will have to divide 1000. You need to remember these things. Okay, let me just write that with it. No, not here, basically here you will say either this or that, right? If this is given to you or this is given to you, you can convert them into liters by just dividing 1000. If milliliters is, if you have liters and you want to convert it into either one of them, you can just multiply 1000. Okay, then you have basic information that 1000 liters, I'm not talking about milliliters now, I'm talking about liters. 1000 liters is equal to 1 cubic meter. Okay, so if I want to convert liters into cubic meter or cubic meters into liters, I have to first, liter into cubic meter is going to be divided by 1000, and cubic meter into liters is going to be multiplied by 1000. Other than that, we have cubic meter into 1 million milliliter. Basically, this is really important for you to understand. Okay, if 1 cubic meter is equal to 1000 liters, and we already know 1 liter is going to be equal to 1000 milliliters, right? 1 liter is 1000 milliliter, so 1000 liters is going to be 1 million milliliters. So basically, if you want to convert cubic meter into cubic centimeter or milliliter, then you will have to multiply a million. Okay, cubic meter into cubic centimeter or milliliter is going to be multiplied by a million. Or if you have cubic centimeter and you want to convert it into cubic meter, you will have to divide it by a million. You have to remember at least these few things. You need to remember them, memorize them. Okay, write down all the things that we have done. This is basic information. Without them, you won't be able to solve this chapter, or let alone understand anything in this chapter. So you're gonna write this down, okay, and memorize them. That was the basic concept about volume, area, surface area, cube, and cuboid. Volume is what? Space in a 3D shape. So area is what? Area is space in 2D shape. But what is surface area? Surface area is basically when you combine all the external faces, area of external faces of all the real things, real 3D shapes. If you add them all together, that will be surface area. Cube is what? Cube is basically what square is in 2D shapes, but we have it in 3D here. And cuboid is what? Cuboid is basically the rectangle in our 3D world. Now we're gonna be dealing with formulas. Okay, this is again very important, so you need to pay attention and remember these things. Volume is equal to length multiplied by breadth multiplied by height. Just like area is equal to length multiplied by length, we've done this, right? Length multiplied by length. Volume is going to be equal to length multiplied by breadth multiplied by height. What is length measured in? Length is measured in meters. What is breadth measured in? Breadth is also measured in meters. Basically, I'm saying the unit, if it can also be measured in centimeters, yeah. But right now, we're just saying that if length is measured in meters, then we can just replace it with an m. Breadth is also going to be replaced with an m. Height is also going to be replaced with an m. And that's why the unit of volume is going to be meter cube. M multiplied by m multiplied by m is going to be meter cube. As long as you understand what exponents means, right? Exponent means, for example, just a recap. If I have any number, for example, I have 3 raised to the power of 2. What does this 2 means? 2 means 3 is being multiplied by itself 2 times, right? I have 4 raised to the power of 6. What does this 6 means? 6 means 4 is being multiplied by itself 6 times. 1, 2, 3, 4, 5, 6. That's what exponent means, right? So m cube basically means m is being multiplied by itself 3 times, and that's what the formula is, okay? And that's how we get the units of volume is in cubes. Units of volume are always going to be in cubes because we have 3 dimensions being multiplied with one another. Length is being multiplied with breadth, is being multiplied with height. And that is why area is in squares, because only length is being multiplied with breadth, or you can say length multiplied with length in area. Okay. Volume of cuboid. Basically, One more thing is that you have this cube, right? Cube, all the lengths are same, length, breadth, and height. For example, let's just say, let's for the sake of concept right now, it doesn't really matter much, but let's for the sake of concept, we say the vertically upgoing line, this line is going upwards, that's why it is height, and this horizontal line is going to be what? This horizontal line is going to be our length, and this one is going to be our breadth. So length multiplied by breadth multiplied by height. All of them are going in different directions. One is going upward, one is going horizontally, and the other one is going basically backwards or forward, right? It's a different dimension. All of them have 90-degree angles between them, and if you multiply all of them, you will get volume, right? In a cube, all of them are length, breadth, and height. They're all equal. Length, breadth, and height, they're all equal. That's why in a cube, we can simply just say length multiplied by length multiplied by length, which is length cube. This is the formula of volume for a cube. For a cuboid, like for example, let's just say this cuboid we have, length is different from breadth, right? Length is different from breadth, and that is different from height. So all of them are different from one another. That means it's a cuboid. Again, in a cuboid, length must be different from breadth and height, okay? At least two of them should be, or at least one of them should be different. Basically, in a volume for a cuboid, for a shape to be cuboid, one of them must be different. For example, if this is 6 and this is 6, this must be other than 6, okay? This is 6, this is 6, this should be 7 or 8 or 9 or 10 or whatever it is, but it shouldn't be 6, okay? If it's 6, then all of this would be a cube. This must be different from at least one of them. All of them can be different. For example, length can be 6, this can be 4, this can be 5, doesn't matter. At least one of them must be different for it to be a cuboid. The reason why we're using length multiplied by breadth multiplied by height is basically just to show that L is different from breadth, is different from height. Okay, it's just a formula. For now, you need to make sure that you remember what volume of a cuboid is, or basically what the formula of volume is. Even this formula, which is for cuboid, what we said, right, is same for a cube as well, because a cube also has length and breadth and height. But since breadth and height are the same as length as well, so we don't bother writing breadth and height. We just simply say it's length and length. Okay, other than that, we have done something before in chapter number 6, basically, linear equations, 6.2. In 6.2, we did something like this. Speed is equal to distance divided by time, right? We've done something like this in chapter number 6.2, right? What is, let's say speed is s, distance is d, and time is t. If I know any one of them, I can find the, if I know any two of them, I can find the third one, right? So if distance and time is given, I can find the speed. If speed is given and distance is given, I can find the time. If time is given, I can find if time and speed is given, I can find the distance, right? If any two of them is given to me, I can find the third one. We have done something very similar, right? We've done this in chapter number 6. Okay. Basically, what I want to say is that in the formula of volume, if all three of them are given, I can find the fourth one. We have about 4 variables here, right? So if 3 of them are given, I can find the fourth one. If, for example, length is given to me and breadth is given to me and height is given to me, I can find volume by multiplying them. If volume is given to me and breadth is given to me and height is given to me, I can find the length by using this, okay? Basically, both of them are being multiplied here on this side of the equation. So what is multiplied is going to be divided on the other side, right? So volume divided by breadth multiplied by height. So length is going to be equal to volume divided by breadth multiplied by height. I can find length if the other 3 are given to me. I can find the breadth if the other 3 are given, and I can find the height if all the other 3 are given. Same goes for volume. So if any one of these 4 variables is required and the other 3 are given to us, I can find it easily. Just the basic thing that we're going to do in this chapter. It's pretty similar to what we've done before, just a basic recap. Other than that, we have total surface area. We discussed what surface area means, right? We discussed what it means, but we need to now understand basically what and how to find it. Before that, in 9.2, we basically have done all the properties that we need to discuss about a cube and cuboid. We're just going to do something simple, which is making the net of a cube. What does this mean? I will show you. This is a cube that I made from a piece of paper, right? It's a cube just like the Rubik's Cube, right? So I'm going to open it up, right? First of all, I have 6 faces of a cube, correct? All of the faces are different, are facing in a different direction. Like this one is facing this way, this one is facing this way, this one is facing upwards, So all of them are facing in a different direction, right? I'm gonna open it up. The cube that I had basically will look something like this, right? This is the net. This is what it means. When I make all the faces look in the same direction, that will be the net. I can just fold it back into a cube as well, like this. Yeah, and now it goes back to a cube shape. Okay, similarly you can do the same for a cuboid. You will have to make rectangular faces instead. They've already made it here as a basic recap. Net, what does this basically tells you? That means this is all 6 faces of a cube when you make them spread out on a piece of flat surface, right? 1 face, 2 face, 3 face, 4, 5 and 6. You have a total of 6 faces of a cube now facing in the same direction. All of them in the original cube face in different directions, right? They're all facing in different ways. Again, here you can clearly see that each face is a square. Each external face is what? A square. Square is what? A 2D shape. So cube is a 3D shape that is made from 2D shapes. Small, basically cube square shapes. You have a cuboid. Cuboid is made from rectangular. Rectangle is what? 2D shape, right? So we have rectangle here, rectangle here, rectangle, rectangle, and rectangle, and rectangle. You have about 1, 2, 3, 4, 5, and 6. Again, you have 6 faces. All of them are rectangle. 2 of them are equal. For example, this is equal to this one, this is equal to this one, and this is equal to this one, right? Just like in the real one as well. The top is exactly the same as the bottom. The left side is exactly the same as the right side, and the front is exactly the same as the back. So they're in a pair. Okay, we have this net. Why is this important? Basically to understand the formula when we're discussing the total surface area. Total surface area, what did I say about total surface area? Total surface area is the total area of all the faces of a real object. Let's talk about a cube. A cube has this. Let's say this is the top face. Top face is length multiplied by length, correct? So we write that down, length multiplied by length, plus again the bottom face, length multiplied by length, so we write that down. Then we have the front face and the back face, so that is also length multiplied by length and length multiplied by length. Then we have the right and the left face, so it's also going to be length multiplied by length plus length multiplied by length. You add them all together, area of each face. This is the area of each face, you're adding them all together. So basically length multiplied by length is length square, right? And length multiplied by length is length square. You have how many? 1, 2, 3, 4, 5, 6. 6 faces, so you have 6 areas, and when you add all them together, you will have 6 multiplied by L square. You can write L square like this as well, and this will be the total surface area of a cube. You need to remember this formula, okay? We're going to use it over and over again in this chapter. So if someone asks you to find the total surface area, or just if they're asking you to find the surface area of a cube, what are you going to do? You're going to multiply 6 with L square, okay? It is a bit different from area. You need to remember this. It is not just area, it is the sum of all the faces, area of all the faces, right? Okay, what about a cuboid? Cuboid is a bit different. Take a look at this. We have length, let's just say this is length, and this is breadth. Length multiplied by breadth. We write that down first, okay? Then we go to the bottom face. Again, length multiplied by breadth. We write that down, plus, then let's just say this one. Breadth, oh, yeah, okay, fine. This was our breadth, right? And this is our height. So breadth multiplied by height. This time breadth multiplied by height. So we write that down. Then again we have breadth multiplied by height. So we write that down. Then we have again these faces, length multiplied by height and length multiplied by height. We write all of them down, and when we're going to add them all together, length multiplied by breadth is basically LB. If you remember correctly, whenever there is nothing between two variables, there's a multiplication sign. So we just remove the multiplication sign and let them be like they are. Length multiplied by breadth, LB, LB, and BH, and BH, and LH, and LH. Add them all together because they have the same variables. Okay, so LB plus LB is going to make it 2LB. You will have 2BH and you will have 2LH. Okay. When you're basically, now this is your simplified version. You cannot simplify it any further, but if you can apply, if you reverse the distributive law, since 2 is being multiplied with each term, you can take 2 as common and you can put the rest of the terms in bracket. So 2 multiplied by LB plus BH plus LH. This will be your formula of total surface area. You need to remember this, memorize it, and make sure you don't forget it. You can also use this if you want, this formula, but it's more easier to just simply use this one, and we're going to be using this one. 2 multiplied by LB plus BH plus LH. So you're going to multiply length with breadth first, okay, multiplication first, then plus, again multiplication first, plus, then multiplication first, right? And then after you're done with the multiplication, then you're going to add them all together. Once you get your answer, you're going to multiply it with 2. That will be your total surface area for a cuboid. Again, one more thing that you need to remember is length, breadth and height. They must be in the same unit of length. For example, if length is in meters, breadth and height must be in meters as well. If length is in centimeters, then breadth and height must be in centimeters as well. They need to be in the same unit of length. If they're not, then your calculations will be wrong. Okay, dimensions, length, breadth and height. They are basically called dimensions, lengths. Okay, what do I mean by that? We're talking about 3D shapes right now, right? 3D shapes have 1, 2, 3 different dimensions because they're 3D. All of them are different, right? Length, for example, even in a cube means that length, breadth and height are going to be same. But fundamentally, just taking a look at this is going horizontal, this is going vertical, and this one is going up and down basically, right? So they're all going in different directions. They're not exactly the same thing. Just like in an area of when we're talking about area, for example, let's just say this is a rectangular face, right? A rectangular face, length is going this way, height is going this way, breadth is going this way, you can say, right? So they're both going in fundamentally different directions. They're not the same thing. They are different. So what is length, breadth and height? They're basically dimensions, or you can call them lengths. This was basic concepts that you need to understand before dealing with the questions of this chapter. As long as you understand what volume is, what area is, what cubes are and what cuboids are and what total surface area is, you will be able to solve this chapter easily. Even if you forgot a few things or didn't understand a few things, for now, just make sure you remember the definitions of what they are. Okay, fundamentally, basically, what is area? Space inside a 2D shape. What is volume? Space inside 3D shapes. Okay, what is total surface area? When you measure the area of each face and add them all together, that is total surface area, or simply the surface area of a 3D shape. What is cube? Cube is basically a 3D real shape with 6 faces, and all of them must be. What is the most important thing about a cube that we are supposed to remember? Basically, if I tell you that I have a cube of, let's say, 12 centimeter, this is all the information that you need to know. You shouldn't ask me that what is the breadth, what is the height. No. If length is 12 centimeter, if I tell you that the cube is of 12 centimeter, then everything, length is also going to be 12, breadth is also going to be 12, height is also going to be 12. Just by knowing that this is 12, you can just say 12 multiplied by 12 multiplied by 12, and you will be able to find the volume. That's the most important thing that you need to understand about a cube. Okay? My purpose of explaining what a cube is, even though we have done this in the previous grade, was to make sure that you understand the difference between a 3D shape and a 2D shape, fundamentally, right? Because those are basics. If you don't understand them, then you won't be able to imagine the figures that are made in these chapters, the questions that are given in these chapters. We have a cuboid. Basically, what a rectangle is in 2D shapes, a little bit different from cube, but it is again a very simple 3D shape. We have much more complicated. Look, you have a book. Book is also, let's just say, I have this register with me. This is also a what? It's a cuboid. I have a rectangular face. Rectangular face here as well. Rectangular face on this side as well, and on this side here as well. This is a rectangular face. It has how many dimensions? One is the length. Let's just say this is the length. This is the height, and then this is the thickness, which we call breadth. You can call it breadth or whatever. Look, the thing is, height, length and breadth, they are going to be different. They're going to go in different directions. They're going to be in different directions. If length is vertical, then the height will be, or breadth will be, horizontal, and the other one is going to be from top to bottom, going in a different directions then. Okay, so these are basic things that you need to remember. Then you need to make sure you memorize these conversion of units, how you're going to convert them, and what are the formulas of volume, and what are the formulas for the total surface area. In the exercise, I'm going to keep calling them TSA. So you need to make sure you remember that total surface area is TSA. Okay, on page number 155, we have the class discussion. Let's try this out. A cube has a dash many faces. How many faces? A cube has 6 faces. Each surface is in the shape of square. The area of each face is going to be what? Length multiplied by length, because it's a square. The total surface area of a cube is, you're just gonna add all them together. Length multiplied by length plus length multiplied by length, you will get 6L square, right? A cuboid has how many faces? It has 6 faces, basically 6 surfaces as well, you can say. Each surface is in the shape of what? Rectangle. And the total surface area of a cuboid is going to be, just add the surface, add the areas of all the rectangles together. You'll get the formula that we've done before. Length multiplied by breadth plus length multiplied by height plus breadth multiplied by height. Okay, make sure you remember these things at least. Okay, basically we're going to start our exercise now, starting with the very basic things. First, whatever is given to you, which is in question number 1, we're given cubic meters, and we need to convert the cubic meters into centimeter cube, or cubic centimeter basically, right? So starting with part 1, 4 cubic meters given to me. So what am I going to do? 4 multiplied by a million. I will get 4 million cubic centimeter. Okay, so if you want to convert cubic meters into cubic centimeter, you're just going to multiply a million with it. Okay, so basically in the first part A of this question number 1, you're going to multiply a million. In part B, you have cubic meter given to you and you want to convert it into you have cubic centimeters given to you and you want to convert it into cubic meters. So what are you going to do? You're going to divide a million. So part 1 is your homework. Try that by yourself. And part 2, I've done it here in front of you. Yeah, some student might have difficulty in division. Okay, so for example, in part 2, you are given 67,800 cubic centimeter. You're going to divide that by a million. So what are you going to do? A million has how many zeros? 1, 2, 3, 4, 5, 6. A million has 6 zeros. So you're going to jump 6 times. 1, 2, 3, 4, 5, 6. You're going to jump 6 times. So you're going to add a point after that. Okay, so we got 0.0678. Basically 0.0678 is going to be your cubic meter volume, right? Same goes for part 1. Part 1 is 250,000, right? So you're going to jump 6 times here as well, and you'll see where your dot lands and you will decide the answer. Basically that's how you divide by a million. And the same division goes for every other one as well. For example, if you're dividing by 1,000, 1,000 has 3 zeros, so you're going to jump the decimal point 3 times. And this was just a basic revision. You've done this before, and even grade 4 students have done this. So this was basics, very basic. Try this out by yourself. Question number 2, basically again, we need to this is unit of conversion of units. The cubic meter is given to you and you gotta express it in 2 different other units. We have cubic centimeter and you have milliliters. So first you're going to, for you to convert cubic meters into cubic centimeter, you're going to do what? You're going to divide it by a million. Okay, and you want to convert that answer into milliliters. Basically the same thing, because 1 cubic centimeter is equal to 1 milliliter. That's why the answer that you get from here will be the answer for this one as well, just the units will be different. Okay, that's why part A is going to be your homework. Part B, I've done it here. Cubic centimeter is given to me in part B of question number 2, 2,560 cubic centimeter. This is what given is, and they're asking me to convert it into cubic meters, and they're asking me to convert it into liters. Yeah, they're asking me to convert it into liters. So first of all, I'm going to convert it into cubic meter, part 1. Okay, we have cubic centimeter going into cubic meter, and for that we need to do what? I've already done this before here. Yeah, multiply by 1,000 and divide by 1,000 depending upon what you're doing, right? So right now we're going to convert cubic centimeter into meter, I hate saying this, cubic centimeter into cubic meter. So you're going to divide by a million. That's what we did here. Divide by a million. We're going to jump 6 times and we get 0.00256 as your volume. Make sure your units are correct. Okay, this conversion of units is really important because we have an incident happened at NASA. Basically, scientists, if they're not careful about these units, everything can go wrong really badly. Okay, so there's an example in NASA. Back in the time, they used to use different units in British and different units in France. The British used to use different units and Americans used to use different units. So the calculations that American peoples did were in a different unit, and the answer that they got was different from the ones that the Germans and French people interpreted, and that's why they launched the satellite with wrong calculations, and that caused an accident basically. And after that, basically these units were established a proper standard units were established that you're mostly supposed to use a cubic meter when dealing with volume. So you've got to be really careful about these units that you have, okay? Going back to the topic, we had question number 2, part B. We're going to do part 2 of part B. Basically, you're going to convert the cubic centimeter that is given to you into milliliter first, then we're going to convert it into liters, because milliliters into liters is easy. Milliliters into liters is basically divided by 1,000. Whatever you have in the cubic centimeter is basically the same in the milliliter as well, because 1 is equal to 1, right? So if you have 2,560 cubic centimeter, you have 2,560 milliliters, right? You're going to divide that by 1,000 to know how much liters you have. Basically 2.56 liters you will have. This is basic conversion of unit. You should practice this by yourself. After that, we have question number 3. Again, very simple, very easy. We have done this before in grade 5. They're asking you to find the volume and they're asking you to find the total surface area. The figure is given to you. Let's just say all the horizontal, okay, let's just say this is length, this is length, this is our height, and this is breadth. Okay, the point is that all of them are different here. It's a cuboidal shape, right? So I've done part A here. First, I'm going to do what? I'm going to find its volume. Volume is equal to length multiplied by breadth multiplied by height. Length is given, breadth is given, height is given. So I'm just going to multiply them and I will get my answer. Now, this is where your marathon is really important, right? You've done marathons, you've done multiplication over and over again. So if you're good in multiplication, these questions will be pretty much very easy for you. But if you are weak in multiplication, then they're going to take a long time unless you use a calculator. So yeah, volume is going to be equal to length multiplied by breadth multiplied by height. Just put the values and multiply them. You'll get your answer. Then part 2, you need to find the total surface area. Now this can be different depending upon what you're doing. For example, this is a cuboid, right? This is a cuboid. So the formula for the total surface area of a cuboid is what? It's 2 multiplied by length multiplied by breadth plus length multiplied by height plus breadth multiplied by height. You're going to just put the values. We know what length is, we know what breadth is. Just put their values, okay, and solve it further. You will get your total surface area, right? In this question, the length is what? Length is 8. The breadth is what? Breadth is 6. So length multiplied by breadth, 8 multiplied by 6. Then what is length and height? Length is 8, height is 10, so 8 multiplied by 10. Then breadth is 6, height is 10, so 6 multiplied by 10. You're going to multiply first and then you're going to add, okay? Don't forget the rules. Multiplication first and then addition. Do that, and then in the end, again, you have to multiply the answer with 2 and you will get your answer, which is the total surface area of part A. Then part B is a cube. Pretty much very simple. Cube in which you have to volume, length multiplied by breadth multiplied by height. So 7 multiplied by 7 multiplied by 7. And also make sure you remember this, that the total surface area of a cube is different. The formula for total surface area of a cube is basically this, 6L square. Length is given to you, so you're going to say 6 multiply with 7 with the power of square, okay, raised to the power of 2. Then you're going to 7 multiply by 7 first, which is 49, and then you're going to multiply 49 with 6 to find the total surface area. Part B and C are your homework. Try them by yourself. Part D, I've done it here just because it has decimals in it, so I'm going to do it. Again, be very careful of the units that you have. For example, here you have millimeter, so the answer that you're going to get is in millimeter square and millimeter cube. Here we had centimeter, so the answer is going to be in centimeter cube and centimeter square, right? Here we have centimeter, so the answer is going to be in centimeter square and centimeter cube, right? First of all, just multiply them. Point division, you know how to multiply points, right? So just multiply them one by one at a time, and this will be the volume that you will get when you multiply length with breadth and height. I just showed you an example here. The total surface area for a cube is different from a cuboid, which is 6 multiplied with length raised to the power of 2, right? So what is length? Length is 5.8. So 5.8 with raised to the power of 2. 5.8 multiplied with 5.8. First, you're going to deal with this. Okay, you get this answer. We've already done this one here. So 6 multiplied with that, then you will get your total surface area. This is the exact value and this is the approximate value. Approximate means almost the same. Almost. Look, 201.84. 0.84 basically means it's 2. So 202 basically you can say. Approximate value is this, if you want to talk about it in whole numbers. Then part E, I did part E here because it had fractions in it. Volume is equal to length multiplied by breadth multiplied by height. So the length given to us in the question is 5 by 8. Breadth given to us in the question is 3 by 8. And height given to us is 1 whole 2 by 5. what you're going to do, you're going to multiply the fractions. Okay, how do you multiply the fractions? Denominator multiply by the denominator and nominator multiply by the nominator. So 8 multiplied by 8 is 64 and 5 multiplied by 3 is 15, right? And multiply by, I converted this whole number into a fraction, normal fraction. We have 7 by 5 then, right? Now remember this, we have a what? A multiplication sign between them. So this is why I can cancel each out, right? So we have a 15 here and we have a 5 here. They come in the table of 3. That's why, sorry, 5. So I'm gonna cancel them out. 5 ones are 5 and 5. Basically, I'm simplifying the fractions here so that the multiplication can be easier for me. I can just proceed with the multiplication here, but then it'll be hard for me to multiply 5 with 64 and then simplify it later on. So from the start, 5 divided by 5 will be 1 and 15 divided by 5 will be 3. So 3 multiplied by 7 then will be 21 and 64 multiplied by 1 basically will be 64. I'm left with the fraction as my volume. It's okay, it's completely fine. You can convert this into decimals if you want, you can convert this into whole numbers if you want, or you can just simply leave it as it is. It's perfectly fine. My point was to show you the multiplication of fractions, just in case if you forgot. Now that was easy. Now we have the total surface area. This is going to be a bit more difficult because we will have fractions multiplying fractions and then them being added together and then multiplied with 2, so it's going to take a bit longer. First of all, length, which was 5 by 8, right? Multiply by breadth. We already know the formula. Don't forget the formula, okay? Formula was what? Wait a second, again. Yeah. This is the formula, don't forget it, okay? So the length is what? 5 by 8. So 5 by 8 multiplied by breadth. What is breadth? 3 by 8. So 5 by 8 multiplied by 3 by 8, then plus length multiplied by height, then what? Breadth multiplied by height. So you're going to do them. 8 multiplied by 8 is 64, 8 multiplied by 5 is 40, 8 multiplied by 5 is 40. All the denominators I've given you. Then you proceed with the multiplication of nominators. Once you get your proper fractions, now we need to add them together. Again, since there is a plus sign, I cannot cancel anything out right now, okay? And I can only add them if the denominator is same. So 40 and 40 are same, that's why they can be added together. 64 is different, so I'm going to leave it right now. I'm going to take 40 and 40 common, so 35 plus 21 is going to be 56, right? 15 by 64 will come down as it is. 2, again, outside the bracket for now. Now, I could have just proceeded with multiplication here, but I simplified it first. Since this is an even number and this is an even number, I know that they can be simplified by 2, right? So 2 ones are 2 and 32s are 64. That's why we get a 34 here and we get a 15. So 15 by 34. Then we had a 56 and we had a 40 here. Again, 2 ones are 2 and 2 20s are 40. So we get a 20. Then again, this was an even number and this was an even number, right? We had 56 which was even and we had 20 which was even. So I'm going to cancel them out as well. Again, I'm going to simplify it even further, right? So 2 28s are 56 and 2 10s are 20. I can simplify it further. So 2 5s are 10 and 2 14s are 28. I'll be left with 14 by 5 as the most simplified. I cannot simplify it further. Plus 15 by 32. Now I can just simply add them. No, we have to make sure that the denominators are same. If this is 32, then this must also be 32, but they're not, so we're going to make them same. Do they come in the table? Do they come in the same table? No, they don't come in the same table. That's why we just simply need to multiply them. 35 multiplied by 32 multiplied by 5 and 15 multiplied by 5, while 14 multiplied by 32 and 5 multiplied by 32. You will get 160 as the common, and 75 plus 448. Add them together, you get 523 divided by 160. Now this cannot be further simplified, so that's just going to be your total surface area. This was a bit difficult, basics fractions, but you have to make sure that you understand how to deal with fractions. Again, my purpose here was to show you how to add and multiply fractions. Other than that, this was basic things that you've done before. Just multiplication and division, multiplication and addition of fractions. Then we have question. Yeah, part F. Now we're going to deal with part F. It has, again, what? A fraction. But we're going to convert this fraction into decimals because it's easier. You know how hard it is to deal with fractions. We've just shown you an example in the previous question. So what are we going to do? It's 1 whole 1 by 2. What is 1 by 2? 1 by 2 means half. And what is half? Half is 0.5. Okay, so 1.5. When you convert this fraction into decimals, you will get 1.5, right? So first convert this fraction into decimals. Again, this is a cube, so if the length is given, then breadth is also the same and height is also the same, and all of them are the same, right? All the lengths are going to be the same, so all of them are going to be 1.5 centimeter. That's what we did here. Volume is going to be length multiplied by breadth multiplied by height. Length is what? 1.5. Breadth is what? 1.5, and height is also 1.5. Multiply them and you will get your answer, which is 3.375 cubic centimeter. Then again, total surface area is also simple. First we have 6 multiplied by length square. What is length? 1.5, so 1.5 square. 1.5 square means 1.5 multiplied by 1.5. You just multiply them, and then you can multiply the answer with 6, and you will get your answer, which is 13.5 cubic meter. Oh, sorry, I was wrong. It's cubic centimeter. Yeah, make sure the units are right. Even I made a mistake here, so you gotta make sure that your units are right. Okay, it's centimeter, cubic centimeter. And yeah, remember, square, cube, okay? Don't make a mistake in this at least. We have volume in cubes and surface area in centimeter or square basically. Question number 3 done. Question number 4. You're gonna do this in your notebook, okay? This is what I was talking about. We have done this in we have done very similar things in chapter number 6. Exercise 6B basically, yeah. It was 6B. When we have a formula, any formula, for example, even this formula, right? How many variables do I have here? 1, 2, 3. I have 3 variables. Basically, not 3 variables. I have 2 variables, which is like, this is the other variable, the total surface area, right? Total surface area is also a variable. We don't know that, right? And length, breadth, and height, they're all variables. How many variables do I have? 1, 2, 3, and 4. A total of 4 variables I have here, different 4 variables. If I know any 3 of them, I can find the 4th one, any 3 of them. A very simple example is what we've done here, yeah. 1, 2, 3, 4. I have 4 variables. If I know any 3 of them, I will be able to find the 4th one. If I know V, L, and B, I can find the H, okay? If I know H, L, and V, I can find the B, okay? So that's exactly what we're going to do in this question. First of all, length, breadth, and height is given, which is very similar to what we've done in the previous question. Just multiply them and you'll get your volume. Then height is missing, but volume is given to us. So what are we going to do? We're just going to use the linear equations to solve these questions, okay? And once you get your height and all this part is complete, you can easily find the total surface area. As long as you have length, breadth, and height, you can easily find the total surface area. Okay, in question number 4, it says in the question that these are all what? Cuboids. So what are the things that we are supposed to remember about a cuboid? Volume is equal to length multiplied by breadth multiplied by height. This is just a general formula of volume. It's applicable on cubes and cuboids as well, okay? Just in case of cubes, all of them are going to be equal. So you're going to remember this, and you're going to remember this. The total surface area for a cuboid is equal to 2 multiplied by length, 2 multiplied by length multiplied by breadth plus breadth multiplied by height plus length multiplied by height, okay? So you got to remember this. Now, going step by step. First of all, in the first part of question number 4, length is given, breadth is given, height is given. You need to find the volume, you need to find the total surface area. So what is how are you going to find the volume? Just multiply the given data together, you'll get the volume. Then you have total surface area. Put the values in place of length, you will put length. In place of breadth, you will put the breadth. For example, in place of length, we will put 22. Again, right, 22. And in place of breadth, we're going to put 18. So 24 multiplied by 18 plus 24 multiplied by 5 plus 18 multiplied by 5. Do multiplication first, and then you're going to add the answers. Altogether, whatever you get, you're going to multiply that with 2, and you'll get your total surface area. Okay, in question number B, now this is where we're going to basically do something a bit different. We have length given to us, we have breadth given to us, and we have height, okay? Make sure you're careful about the units. They're in centimeters now, right? So, length given, breadth given, height is missing. Volume is given, and total surface area is also missing. They're asking us that, right? So, length is equal, first we're going to find what height is from this formula. We know volume, we know length, and we know breadth. So, we're going to put the values. Volume is 120, length is 5, and breadth is 3. What is going to be our height? We're just going to leave it as it is because we don't know that. So it's going to stay our variable. 5 multiplied by 3 is 15. Now 15 is being multiplied with h. So what do we have to do? We have to divide 15 on both sides of the equation. And 15 divided by 15 cancels out. We will be left with h. And 120 divided by 15 will give us 8. So 8 will be the value of h. What 8? 8 centimeters, because all this calculation was done in centimeters, right? So 8 is going to be our, see how I was able to do it? Like just by knowing other three, I was able to find the fourth one. Any of them, I can do the same for any of them, right? If I know the volume and the other two, I will be able to find the third one, whichever one of these is missing, right? Total surface area, now that I know the height, after knowing the height, I can easily just put the values and I can find the total surface area as well. The same goes for all the other parts of this question. I've done them. That was part B, right? So part C. Length is missing in this case, breadth is given, height is given, and volume is also given. Again, the same thing. Volume is equal to length multiplied by breadth multiplied by height. We're going to leave L the same way as it is because we don't know its value, so it's going to become our variable. We know the value of B, which is 6. We know the value of H, which is 3.5. Just multiply 6 with 3.5, and whatever you get, you're going to divide the volume with it to find the value of L. Once you know L, basically, you have all the data needed for you to find the total surface area. You know the value of L, you know the value of B, you know the value of H now, so you can find the total surface area by just putting the values in the formula. The same goes for part D. You have the length given, breadth is missing, height is given, volume is given, and total surface area is also required. So what are you going to do? Again, in the same formula. Volume is equal to length multiplied by breadth multiplied by height. Volume is given, so you're going to put its value. Length is given, so you're going to put its value. B, you're going to leave it as it is, since we don't know what it is. And H, we're going to replace it with, H is going to be 6 because it's 6 meters. Now our calculations are in meters, right? So just proceed with the linear equation. You will get the, solve the linear equation, you will get the value of B, which is 8 meters. One more thing I want to remind you of is that these formulas are not your simple linear equations, right? They're non-linear equations. They are algebraic expressions and equations, yeah, sure, but they are non-linear because variables are being multiplied by itself, or multiplied by each other, right? So doesn't really matter. The method remains the same. We have multiplication is happening, so to remove the multiplication, we're just going to divide, just like we did in linear equations anyways. Okay, now that you know the breadth, length, and height, you can find the total surface area again here as well. In the same way, nothing's different. This is basically what you need to practice over and over again. There isn't any much different. Any one of them. If length is given and breadth is given and height is missing, if breadth and height are given and length is missing, if length and height is given and breadth is missing, all you need to use is the formula of volume. Okay, just make sure you remember the formulas. Volume is equal to length multiplied by breadth multiplied by height, and the formula of total surface area as well. You're going to remember them and you can just apply them and be easily able to solve these questions then. Okay, one more thing. Question number 5 then. Basically, up until now, everything that we've done is basic level stuff. All of them were like, most of them were what we've done in grade 5 and what we've done before as well in chapter number 6. Question number 5 here. Again, very simple, very similar to what we've done before in question number 4. Question number 5, the dimensions are given by, okay, length is given, height is given, breadth is not given to you, and the volume is given to you. Can you find the breadth? Easily. Volume is equal to length multiplied by breadth multiplied by height. So you're going to replace L with its value, H with its value, leave B as it is, and replace volume with its value. You can find the value. You can find the value of B, which is going to be your breadth, right? Once you find B, now here is when things get important. Part 2 of question number 5. Part 1 was easy, very similar to question number 4. Part 2 is where things get interesting a bit, okay? So you're gonna make sure you pay attention. Basically, the total volume, which is given in the question, which is 6,720 cubic centimeter. That is the total volume. They're saying that cuboid is melted, this cuboid is melted to form smaller cubes of length 4 centimeter. How many cubes can be obtained? What does this mean? First of all, what is the total volume? Total volume is given in the question, which is 6,720. The smaller cube's volume. What is the smaller cube's volume? Smaller cube's length is given to us, which is 4. So since it's a cube, we're just going to multiply 4 with 4 and with 4, right? So we're going to get 64 cubic centimeter. That's going to be the smaller cube's volume. Since the cuboid is being melted to form the smaller cubes, whatever is the volume of cuboids, right? Whatever is the volume of cuboids is going to be the total volume of all the smaller cubes. Basically what I mean is that, for example, I have this box, or you can say something like, it's a rectangular box, right? It has water in it. All of this water, it has a specific volume, right? So that's going to be the total volume of that water. I'm going to pour it into a smaller cubic box, right? The volume of water is not going to change, right? Some of the volume of water is now in this box and some volume is in this box, right? The total volume of the water doesn't changes. How many more boxes, these small boxes that can I fill by all the water that I have in this bigger box, right? So that's basically what it means in this question as well, right? In this question, it says that the cuboid is melted to form a smaller cubes of length 4 centimeter, right? So the volume that we're gonna have for the smaller cubes, right, it's made from the cuboid. The cuboid is melted, so the total volume that the cuboid had is not going to change. It's going to remain the same. So the total volume that we had in the question was basically 6,720. That's going to remain the same. And from that volume, how many smaller cubes can I make that will have this volume, right? The smaller cubes will have 64 cubic centimeter volume. How many of them can fit in the total volume of 6,720? That's basically what we need to find here. So how are we going to know how many smaller cubes of 64 cubic centimeter can fit in the total volume of 6,720? Basically by dividing the total with the volume of each. We've done something similar before in the word problems, okay? The total volume is given and you divide it by each, you will get the number of things. For example, I have a total of 1,000 rupees and I have let's just say one bag of chips cost me 100 rupees. So how many chips can I buy in total? 1,000 divided by 100 will give me 10, right? So I can buy 10 bags of chips, each costing 100 rupees. That's what we've done before in the word problems in the linear equation, basically, yeah. So this is pretty much similar to that. The total is given to us and the volume of each smaller cube is given to us, right? So we're going to divide the total by the volume of each smaller cube and we will get the number of cubes that will fit in the total volume, which is going to be 105. So basically 105 small cubes, each having a volume of 64 cubic centimeter, can fit in the total volume of this cuboid. Okay, total volume of a cuboid of a total volume of 6,720. That's basically what it means. Question number 5 done. Up until now this was basic level questions. Now we're going to deal with some a little bit more your level questions. Up until now this was basically something that a 5th grade student should be able to do. Now we're going to do what is actually of your level, right? So in the next lecture we're going to discuss what question number 6 and the rest of the questions that are left.